Hello students, we are studying which chapter? Matter in our surroundings. Today we will be studying the differences between boiling and evaporation, the other two states of matter, and we will be doing the quick revision of the chapter. So now let us start with the differences between boiling and evaporation. When we are saying boiling is a fast process, isn't it? So it is a rapid vaporization of liquid when it is heated to its boiling point. For example, if you take water, it boils at which temperature? 100 degrees Celsius. As soon as water reaches 100 degrees Celsius, what do you see? Tremendous amounts of vapor over the vessel. Suppose you take a vessel, just boil it on the stove. You will see after some times water starts boiling and tremendous amounts of vapor are coming out of the mouth of the vessel. So you can see in that, you can observe also it is a very rapid process, and when it is heated to the what? It's a boiling point. Boiling point is must. If boiling point is not reached, boiling will not happen. Now, evaporation, when we are saying, what happens? I said to you, if you wipe the floor with wet cloth, isn't it? You don't do anything, just leave it. And you will see after some time the floor is totally dry. Here evaporation has taken place. So here we have not applied heat to it. It is a natural phenomenon and it can occur at any temperature below its boiling point. Now come, boiling, I said it is a rapid process. Yes, it is a rapid process, and evaporation is a slow process. Once boiling point is reached, it goes on faster. But what happens in evaporation? It goes on for a longer period of time, and thus the evaporation takes place. Now, if we are talking about boiling, for every liquid there are different boiling points. I said to you, water boils at 100 degrees Celsius. So it occurs at a particular temperature when the liquid is heated. But when we talk about evaporation, it can occur on its own and at all temperature, any temperature it can be, isn't it? If the room temperature is more, naturally evaporation will be faster. If the room temperature is less, the evaporation will be slow. There are certain factors on which this evaporation depends. Now, when we are saying boiling is a bulk phenomenon. Whole liquid participate in boiling. Suppose if boiling is taking place, and here if liquid is present, what will happen? You will see this whole liquid molecules participate in this boiling, and as the result, what happens? It goes up when it reaches water. It's a boiling point. Now, what happens in evaporation? Suppose in this container, this water is present, and what happens in this? It occurs where? In the surface, isn't it? Not the whole liquid is participating. Here it occurs at the surface, but here all the liquids are participating in water boiling. So this whole is participating, so it is a bulk phenomenon. Here only it occurs at the surface, so it is a surface phenomenon. Now, does boiling cause cooling? देखा है कभी कि boiling cool cause करता है, ठंडा देता है? नहीं ना. It occurs at what? 100 degree Celsius, and it is a quite high temperature. And do you think in this position it can only cause heating, not cooling? But what happens in case of evaporation? It causes what? Cooling, because it takes the heat from the body or from the surrounding, and as the result it makes that area cool. So it causes cooling. These are the differences, basic differences between what? Boiling and evaporation. So we have studied about the three states of matter. What they are? Solid, liquid and gas. Now today we are going to study two more states of matter, the fourth and fifth state of matter, and that is the plasma state and the Bose-Einstein condensate state. Okay, so first we are going to study about the plasma state. Plasma state, in this matter in this state is in the form of ionized gas. So what do we mean by ionized gas? It means the gases are charged. Charge means what? Positively or negatively charged. Okay, these are super energetic and super excited particles. When are these charged particles of this gas caused? When it consists of tremendous amount of energy in it, isn't it? And if energy is there, naturally it will be in its excited state. Example of this plasma state, a fluorescent tube and the neon sign bulb. There are many other examples which we can see. Even the sun and the stars which glows, this has the presence of what? Plasma in them. Okay, these gases are ionized, and this ionized form of gases creates a fourth state of matter, that is the plasma, which are charged when the energy or when electric energy flow through it. So this is about the plasma. Now coming to what? Bose-Einstein condensate state. Here we have in plasma, we have studied about tremendous amount of energy, isn't it? In this plasma, energy and the excited state, what we have studied, isn't it? Here we are studying about the cooling of the gas, totally opposite to this of what? Plasma. They have got, these gases have got what? Extremely low density, and they are at super low temperature. When I am talking about super low temperature, it goes to what? The absolute, what? Absolute zero temperature. And that is what? Minus 273 degree Celsius. Okay, and here at this low temperature, these atoms, they are no longer they are separate. What happens? They start coming close to each other and they form a cluster over there, and thereby making a super atom. What they make? A super atom. Example if we take of this is the superfluid like liquid, what? Helium at minus 273 degree Celsius. So this is all about the plasma state and Bose-Einstein condensate, which you have to know at this level. And with this we come to the end of this chapter, matter in our surroundings, and now we are going to do a quick revision of this chapter. So we are going to do the quick revision of this chapter with the help of a flow chart. Okay, so first matter. Matter is what? Matter is anything which occupies space and has got mass. So what are the characteristic features of the matter and the physical states of matter in this? You can see in this chapter, basically it is divided into three parts, this matter: the characteristics of matter, the change in state of matter, and the physical states of matter. First, we will be seeing what the characteristics of matter. So when we are talking about the characteristics of matter, you have studied particles of matter have space between them, isn't it? They have got space in between them. For this we have just performed an experiment. I had explained you an experiment that take spoon of sugar, add it in water, and what we will see, that the level of the water does not rise up to a certain extent. Okay, till certain period of time we can add the sugar and we don't see any rise in the level. And this is because the particles of matter has got what? Space between them. Now, particles of matter are continuously moving, isn't it? They are moving in which manner? Zigzag manner, isn't it? And how can we see this? How one experiment I had said to you, that just put the pollen grains on the water, we'll see that it starts moving. It starts moving because the molecules of water are moving, and this shows that particles of matter are continuously moving. Particles of matter attract each other. Actually, all the states, solid, liquid and gases, they have the property that yes, when matter is there, if certain conditions are applied, what happens, they attract each other, even though if conditions are not applied in case of solid. Because you see that if you are given iron rod, the experiment which I have explained you earlier, the iron rod, okay, a chalk, the liquid or a gas, you'll see what this iron rod, it is difficult to break, isn't it? Because why? Here the particles of matter attract each other, isn't it? But yes, in different states of matter, these particles of matter which attract each other are at different levels. The more is in the solid state. Now come matter, change in state of matter. Can the state of matter be changed? Okay, so before that saying, I would like to say to you first the physical states of matter. Okay, so these physical states of matter are of basically three types. Okay, and but two other types are also there, that is plasma and Bose-Einstein condensate. Okay, so basically you have to study this solid, liquid and gases state. Solid, I am going to say you about the properties of solid. Solid, you can see, I am saying you about the particles over here. You can see that they are closely packed. In liquid you see that space is there comparative to what? The solid. In gaseous state you see, yes, the space is more than present in the liquid, isn't it? So with this we can say that interparticle space in solid is least. In case of liquid, interparticle space is more as compared to the solid, and in gases it is more in compared to the liquid. So when we talk about the interparticle forces, so interparticle forces are more in case of what? The solid, and liquid has got less than what? Solid, and gases it is too less. Why? Because the interparticle space is the most in case of the gases. When we talk about the density, here the density of solid will be more comparative to the liquid, isn't it? This liquid will have less density as compared to solid, but more density as compared to the gaseous form. When we are talking about compressibility, these solids can't be compressed, or if compressed also to a very less extent. Okay, but in this liquid it can be compressed to a certain extent, but in gases it can be compressed very easily. Now, compressibility we have seen, density we have seen. Now solids have got fixed shape. Liquid doesn't have the fixed shape, and gases also doesn't have fixed shape. These both liquid and gases can flow, and so they are known as what? Fluids. Okay, so here we can see that the shape of a solid is fixed. Liquid and gases it is not fixed. But when we talk about the volume of solid and liquid is fixed, but gases it is not fixed. Okay, so these are the differences which you see between what? The solid, liquid and gases. Now saying about the two other states of matter, right now I have explained to you this plasma, they exist in the ionized gas form, because here the energy is too much. So what happens, they exist in the form of ionized gases, they glow because of the energy, and they are in the excited form. Example, I can say you of the sun, the neon bulbs. Okay, now Bose-Einstein Condensate, I said to you, condensate, it means it is aggregating. So here the temperature opposite to this plasma, the temperature is too low over here. It goes to minus 273 degree Celsius at the absolute zero temperature. Okay, so here what happens, as the temperature is less, what happens, the atom starts aggregating and form a cluster, and that type of atom is called a super atom. Okay, now we are coming to the change in state of matter. Here you can see we have to study the effect of change of temperature and effect of change of pressure. You all know that this, if we keep the pressure high and temperature low, what will happen? It is easy to compress a liquid or a gas. Solid, I said to you, compressibility is what? Very, very, very less or negligible. Okay, so here we are going to see first effect of change of temperature. In this, what happens due to temperature? Suppose if we are taking water, okay, this water, we are doing two things. What? We are lowering the temperature to 0 degrees Celsius, it becomes ice. We are just raising the temperature to 100 degrees Celsius. What happens? It forms a water vapor. Okay, so here you can see I had said to you about an experiment that yes, take the ice in a beaker and put a thermometer inside it and start heating that ice. After some times we will see that what the ice is being converting into, or it is changing into the liquid form. Okay, it is changing into the liquid form, but the temperature is not rising in the thermometer. Actually here the temperature is being utilized what? To change the solid state into the liquid state of water, and this energy is in the hidden form. So I said to you, it is known as what? Latent, and latent heat of fusion. How much energy is being used to convert that 1 kg of the ice into water? Into water. So here what has happened? The ice is being converting into water, but the energy, we can't see that the temperature changing in the thermometer. That happens in case of what? Water also. Heat the water. When it reaches this 100 degrees Celsius, it changes into what? Water vapor, and this process is what? Boiling. Okay, and here we will not see any change in temperature in case of what? The thermometer, because here the energy has been utilized to change the water from the liquid form to the vapor form, and this energy is known as latent heat of what? Vaporization. Latent heat of vaporization. And here it is known as what? Latent heat of fusion. So this is how the temperature plays a great role in changing the state of what? Matter. Like here you can see the solid state has been changed to liquid state, and liquid state has been changed to vapor state. But yes, we can directly with the help of temperature, directly the solid form can be changed into the what? The gaseous form, as we see in case of what? Sublimation. In this sublimation, we have taken the example of ammonium chloride, that is the what? Camphor or the kapoor, which we had taken in the china dish. And here what we had applied heat to it, and it has changed into its gaseous form and got deposited in the walls of the funnel. So here solid has been changed into the gaseous state, and that phenomenon is known as what? Sublimation. Now come to effect of change of pressure. Suppose if you are taking solid, liquid and gas, I said to you that yes, solid will be not compressed because the particles are close to each other. But when we take the example like sponge, what happened? They have pores in it. Although it is solid in nature, the structure of the sponge is that it has got pores in it. As the result, when you compress it, what happened? These pores are consisting of air. It comes out and you see that yes, it can be compressed. Like the rubber band also, you can see their structure is also like that, but it has got some point at which it cannot extend or it cannot be compressed. Okay, so here solids can't be compressed, but liquids, I said to you, it has got space, so it can be compressed to certain extent. But yes, if gases are there, it can be compressed. So if we are compressing a gas, it can form a liquid, and if we are compressing to a too high extent, it forms a solid, like in case of what? The dry ice. In the dry ice, what is dry ice? Solid form of carbon dioxide. In this, the gaseous state, we apply too high pressure to it, very high pressure to it, and temperature is low, it changes into what? The solid form directly. And yes, lessen the pressure, and yes, if we lessen the pressure, what happens? This solid carbon dioxide changes into what? The gaseous form. 1 atmospheric pressure for changing this solid carbon dioxide into its gaseous form. So this is about the effect of change of pressure. Now 2 more things we have studied in this. It was what? Evaporation and what? Evaporation and boiling. So these 2 terms also I am explaining you. Okay, evaporation, here what happens in this, no specific temperature is required. Actually it takes place at any temperature below its what? Below the liquid's boiling point. Here the liquid is being changed to what? The gaseous form. This is what? Evaporation is a surface phenomenon. Actually what happens at the surface, the kinetic energy of the molecules of the liquid increases. How does it increase? It takes the energy from the body or the rest of the liquid, or it takes the energy from the surrounding, and as the result its energy increases, and here the liquid changes into what? The vapor form. But when we are talking about boiling, in this the whole liquid is participating in boiling, because all the liquid molecules, it attains the temperature of 100 degrees Celsius in case of water to change from what? The liquid state to its vapor state. So I said to you right now also, this is a very fast process and it is a bulk process, while evaporation is a slow process because it takes place at any temperature and it is a surface phenomenon. If you are not getting any point over here, just see the other video of the other parts of this chapter and understand it. So this is all. Take care.